your 4.3 to 4.4 packet. This is before the 4.3.4.5 packet. This is the 4.3.4.4 notes packet. If you go to page 11, we have not had a chance to go through integration and U substitution worksheets, so we'll try to just hit some problems on page 11 and 12. Okay. We did number 2. We talked about how we always want to approach the problem from a power rule standpoint. If you can imagine yourself foiling and combining like terms and doing power rule, we should always explore that option. But if something looks too messy or too complicated or radical, prevents us from being able to do that, then at least we've explored option 1, but now we're ready for option 2. So option 2 was U substitution. We highlighted our portion inside the parentheses being our U value. We find du dt. We solve for dt. We make our substitutions. We know that we can't move forward until all the variables are disappeared and only u remains. Once we have that, then we go through, in this case, power rule, because that's the rule that matches up. And then once we apply our antiderivative, we bring our original variable back into our answer. Okay, all right, let's try number 3. Okay, so we look at the problem and we ask ourselves, can we just rely on power rule? There's too much, this is too messy, right? So we can't get the terms to separate under the radical. So we're going to have to rely on U substitution. But before that, we have to get our parentheses to show up. Okay, once your parentheses shows up, then you know that you're dealing with a nice U value in front of you, which is that 4x minus 5. Right? Okay, we find the derivative. Cross multiply. Solve for dx. And now we make our substitution. Okay, I can push that 4 out as 1/4. And now, perfect match with power rule, right? Add 1 to the exponent, divide it by that exponent, and then plus c. Okay, we flip that 3/2 up as 2/3. Okay, and finally, we can combine the coefficients together. This is 2/12, which is 1/6, And then what can we also do? Bring what back? Right, bring the x back, right? Yeah. Okay. Questions there? All right, number 4. This is too complex to do, right? We can't split the fractions up. There's too many terms in the denominator. We know there's going to be a U substitution, but let's go ahead and get those parentheses to show up. This is raised to the 1/5. Right. We know that we're targeting that portion inside the parentheses. That's our U value. And also we want to replace that dx. Okay, that's a nice U value because we know that the derivative is going to go down by 1 degree. That should handle nicely with that x squared. We should get things to work out here. Okay, put this over 1 if you'd like. Cross multiply. Okay, make our substitution. Okay, are we able to get the x's to go away? Yes, good. Okay, x's go away. There's a coefficient of 5/3. Now, looks like we want to be targeting power rule, but is something still out of place for power rule? Yeah, we can't do power rule if the variable's in the denominator. We got to force it up before we can do this rule, right? Okay. Okay, I'll put the 5/3 out in front. Push the U to the 1/5 up to the numerator. Make it U to the negative 1/5. And now we're ready. Okay, now I can do power rule. Perfect match. Okay, power rule, we add 1 to the exponent, so plus 5/5, which is 4/5. Flip that 4/5 up, that's 5/4. (25/12) is my coefficient. And then we have to remember your u is only a temporary variable, so bring your x cubed minus 2 back into your answer. Okay, let me skip to number 6 here. Number 6, integral of sine to the 10th of x, cosine of x. Okay, so if you look at all your integral rules here, there's nothing that matches this, right? So we have to look at U substitution. But to do U substitution, we need to see, we want to force a set of parentheses to show up. I know we see parentheses here, but why do we not just let the U value be the x? Because we see parentheses there. Now, remember, the whole point of U substitution is to make the problem look easier, right? So if you just make a substitution U equals x, you're not making any progress, right? You want the U to be a larger portion of the problem so that it'll shrink to become an easier expression. So we're never going to replace U in for x. If we do, we haven't made any progress. So we know the U value is not x. But how can I get another set of parentheses to show up? What's another way to write this sine 10 of x? Any idea? Where else can I put that exponent? Okay, isn't this the same thing as saying sine x all raised to what? Yeah. We talked about that first semester, right? How we always want to push an exponent outside if we want to go through chain rule. For this instance, we're doing it because we want to find the U value. We want to find a visually an easier spot to find that U value. Okay, so we haven't done anything yet. We just made it easier to potentially pick out a U value. So now let's target our U value being sine of x. So I'm going to underline what I want to replace and see how far I can go. Okay, so U equals sine of x. Right, what's the derivative of sine? Cosine. No, just cosine x. Cosine x times, okay, so what you mean, times 1, yeah, cosine x times 1, that's right. I'll leave that times 1 alone. It's not going to impact us. Okay, cross multiply, solve for dx. All right, let's make our substitution here. Cosine x can cancel out. And now we're left with power rule that we can handle, right? Okay, we go through power rule, add 1 to the exponent, divided by that exponent. Push the coefficient out in front. Or we don't have to, just replace the u in terms of sine x. But if you want to push it, the 11 out in front, you can.
Is it also fun whether it is sine to
That's right, yeah. Different variations are all okay. All right, back page. Okay, let's look at number 11. Okay, there's parentheses, denominator. Any idea what can I rely just on expansion power rule for this problem? Actually, we can. Okay, the reason why is because there's no ugly, there's only one denominator term. We can FOIL this out, distribute this through, and separate into individual fractions, right? We saw a similar problem like this on the quiz, maybe without the parentheses, but we can do all the cleanup without the use of anything more complex than just expanding and using power rule. So let's see how far we can get. There's only one term in the denominator. Let's go ahead and split them into individual fractions. Okay, in order to combine bases, if I'm dividing variables, I can simply subtract the exponents. 4 minus 1/2. Same thing as 8/2 minus 1/2. So that's 7/2. Three minus 1/2, that's same thing as 6/2 minus 1/2, which is 5/2. And now we're ready for a power rule, right? Nice and clean. There's nothing else that we need except power rule. Okay. Add 1 to the exponent. Add 1 to the exponent plus 2/2. Okay, flip the fractions up. 2 times 2/9, which is 4/9. Okay, any questions? Okay, I'll share with you guys tomorrow as well. But here are the topics that you can expect for the test on Friday. Know how to do power rule problems, just like how we did just now. U substitution and change of variable. We'll do a problem with a change of variable where we got to go through that additional substitution. Trig integrals, we did one of those. Definite integrals involving unit circle. Maybe I can do one of those and have us practice that. Definite integrals involving absolute value function. This is where we sketch the graph and we have two triangles and we add up the two triangles, right? Even and odd functions, we did that in class today, right? Second fundamental theorem of calculus, we did that in class today as well. average value theorem. We did that yesterday. That was number 1 on that 4.3, 4.5, right? 1 over b minus a integral. And then this, you'll see this on the test as well. This you saw on your quiz, where if I gave you acceleration, you can take the integral to get to velocity, take the integral again to get to position, and then resolve your plus c and plus k along the way. So maybe we can do a couple of these here. So let me start off with change your variable. Actually, we did this today. Do you guys want to see this, or you think you're okay with this? This is let me like this here, where we made the substitution initially, but then the variable didn't go away, so we had to solve for x in terms of u. Do you guys want to see another one of those, or?
What's the difference between U substitution?
So this one is where the u value doesn't make the x go away. And we had to do another round of substitution to get that x to disappear. Do you guys want to see another one of those? Okay, all right. So this is called U substitution, change a variable. Okay, first thing we do, we see that we're not able to expand, right? We can't distribute the x squared through, or else we'll be breaking order of operation rules. So we know we have to involve U substitution. Let's get the parentheses to show up. Okay, what's our u value? 4 minus x, right? We know there's going to be a problem down the road because we know that this x squared is not going to go away. Right? Degree is too low. But we just know that we have some additional work ahead of us, but we can still work our way through. Okay, so u equals 4 minus x. Okay, derivative. Du dx equals -1, right? 4 goes away. Negative x becomes -1. Cross multiply. Okay. Let's make our substitutions now and see what we need. Okay, good so far. All right, we can move forward. We can move the x squared up. Yeah.
Wait, why would it be -1 du cross multiply?
Mm-hmm.
Du.
Right, du over -1 is the same thing as -1 du. I can put that -1 wherever I want to. Right, divided by -1 is the same thing as multiplying by -1. So just to make it a little cleaner, I'm just going to leave it as -1. Yeah, it's not wrong if you put divide by -1, but ultimately it's still going to be, yeah, divided by -1 divided by -1 is the same thing as -1. Okay, we have to make sure that we understand we can't go through power rule in this state. We have to find a way to get that x to go away. So we have to rely on this assigned equation between u and x to help us get there, right? So what if I solve for x? What's x equal to? If I rearrange this equation.
4 minus
Yeah. And now I have something to get that x to go away. Okay, we still have to do some significant cleanup, but at least we have a path towards our answer. So this we're able to FOIL, right? Before we couldn't FOIL this out, but now we can. So we're going to FOIL this out, and then we'll distribute the negative u to the 1/2 through. Okay, still quite a bit of expansion. I mean, work involved, yes.
Why was it 4 minus u? Why would I put in negative u? It was 4 minus x.
That's the same thing. 4 minus u is negative u plus 4. Right. I'm just rearranging it. But I mean, I like to put the positive number in front just when I FOIL out. It just feels a little bit cleaner. So that's why I did 4 minus u. It's not wrong if you did negative u plus 4 though. Okay, so let's FOIL this out. Make sure you take the time to FOIL, that you're not just distributing the exponent through. We got to write this out twice, right? So this is really 4 minus u times 4 minus u. Okay, I'm going to rearrange this. I'm going to push this negative u to the 1/2 in front because I'm just going to get it ready to expand after I FOIL this out. So this is 16 minus 4u plus u squared. I'm just going to make it 16 minus 8u plus u squared. Okay, we're almost there. Distribute one more time, and we should have everything nice and clean for power rule. Add exponents. 1/2 plus 1 is 3/2. Add exponents again. 1/2 plus 2 is 5/2. Okay, so now ready for power rule, okay? Okay, how does that look? Good. Okay, so we're almost there. We'll flip all the fractions up, multiply with the coefficients, and then don't forget, u is only a temporary variable, so you want to bring your x back into your answer. All right, questions? Okay, so next thing I want to go through is definite integrals involving unit circle values, so trig definite intervals. Okay, so let's do one of those. Unit circle. Okay, so any idea how we can start?
So why don't we do the E over B?
You mean like B minus A over N, things like that, or or you mean 1 over B minus A? That is average value theorem. So if it's asking for average value theorem, it'll specify that. But here, maybe eventually it's power rule, but right now it doesn't look like power rule, right? Okay, but first things first is, well, we definitely don't involve the bounds yet, right? That's the last thing we do. So don't plug power 6, negative power 3 in. That's nothing to do with it. So it may help just to rewrite this problem without the bounds. And I know I can't handle, this is too messy for one rule. We have to rely on U substitution. Okay, how can I rewrite this so that I can pinpoint maybe a U value that I could use?
Sine x and square after.
Right. Anytime that you can get a parentheses to show up, it's going to kind of give you like a helpful direction as to how to start this problem. Okay, so I'm purposely ignoring the bounds because I know the bounds is not going to even play a role until the very, very end. Okay, so we go through our process here. U value. Okay, what's the derivative? Okay, put that over 1 if you like. Cross multiply. Make your substitution. All right, do the x's go away? Yes. Go through power rule. Well, if we look, this is nice power rule problem, right? Everything is cleaned up, no x's in the way, no coefficients to keep track of, which is, I mean, if we did, it wouldn't cause an issue. We just have to make sure we keep track of it. Okay, so we go through power rule. Again, no bounds yet, right? We got to get this integral and du taken care of before anything with the bounds. Okay, what does this become? U to the over 3.
Plus C.
Now we do plus C if we didn't have bounds, but we have bounds, so what's next? Good. So either you convert the bounds to be in terms of U, or you convert this antiderivative to be in terms of X, but we don't want to mix these two together, okay? Right now, these bounds are in terms of X, our antiderivative in terms of Y. Yeah, let's get this back in terms of X. So we'll bring the sign back into our answer here. And now you're ready to insert our bounds. Okay, so let's evaluate. I can, if I want, I can push that 1/3 out in front. So upper bound first, minus, then lower bound. Okay, so unit circle values, sine of pi over 6 is going to be √3/2. I'm sorry, 1/2, right? My bad, 1/2. Minus 1/3. Sine of negative pi over 3, that's the same thing as sine of 5 pi over 3. We know sine of 5 over 3 is √3/2, but negative √3/2. Okay, so we need to at least get to this step. After this step, you can either clean up or you can not, or you may not, don't have to go any further potentially. Okay, any of these variations are fine. Even this is fine, but you do want to get your trig out of, you want to involve, get it down to a numeric value, no trig in the final answer. Okay, so review your unit circle values. Okay, I got time for one more. Which one do you guys want to do? Do you want to do a definite integral with absolute value function where you draw the two graphs and add the two triangles together? Do you want to do an even and odd function, which we did in class? Second fundamental theorem of calculus, which we did in class as well today. Average value theorem, or given acceleration, find position. Okay, you want to do the triangle one? So that's the absolute value function. Okay, let's do that. Definite integral. Okay, absolute value of x minus 3 from -5 to 4. We're not going to do power rule. We're going to sketch the graph and make the create the picture for us. Okay, so let's draw this graph first. We know we're dealing with the region underneath between the x-axis and this absolute value function graph. What does absolute value of x minus 3 look like? Where's the vertex going to be? Any idea? Has to do with this number here. Yeah, opposite. All right, so it's going to be 3, 0. Okay, so from 3, you know that it's an absolute value of x minus 3, which is going to be a v opening up. And we just have to extend from all the way to -5 and over to 4. So you drop the vertical lines, and now you can see we have two triangles, and the definite integral from -5 to 4 of absolute value of x minus 3 is just the area of these two triangles. Okay, so we know that these are all triangles. Triangles is 1/2 base times height. Calculate the width. That's 8. If I plug -5 into the absolute value function, -5, I'm sorry, no, I changed it here. It should be -2. -5 minus 3 is -8. Absolute value of -8 is +8. So we know this order pair is -5, 8, which also tells us that the height of our large triangle is 8. Okay. Plug 4 into the absolute value function. 4 minus 3 is 1. Absolute value is still 1. So my order pair is 4, 1, which tells us that the height is 1. Our width is also 1. 1/2 base times height for both of our triangles. 1/2 base times height. Second triangle, 1/2 base times height. 64/2 plus 1/2. 65/2. Okay, so tomorrow morning, maybe I'll go over the last few topics that we've recently saw, even in odd functions, second fundamental theorem, average value theorem, and being able to make our way from acceleration to velocity to position. That just means we're going to go through power rule twice, plus C's will show up, and we just find the C values along the way.
Are we gonna have one of the things on the test, like I don't think we did, or not the word, like, I forgot what it was called, but where we had like, it was like kind of with the acceleration and velocity, then we had to find out like distance and stuff.
Oh, not so much that. No, we don't have to go through that whole process. You just have, the closest thing is this, where you just have to go from acceleration to velocity to position, and then you got to solve for your plus C's along the way. Okay. All right.
What was the answer to the last one?
Oh yeah, 65/2.
Can you go back to the unit circle one?
Mm-hmm. Was this the one you're asking about?
Yeah.
Okay. Is that what you got? No. Did you guys get this answer? Okay. Okay. Here's the unit circle. That's fine. If you get to this point, I will give you credit too. But you got to get past this point to this point.
I got 1/24 minus 1/3 times -3.
Okay, that's fine. All right, we'll pick up tomorrow.
I have a picture of like all the things.
Sure. Yeah, I'll bring it to you. You can take a picture of this. Oh, I see. This one here. Okay. Yeah, if you guys get a chance, see if you can get started with the test review on the handout that you most recently got. Page 3 and 4 is the test review, so you can start working through that if you like. Okay, but we'll go through that packet or continue with that packet tomorrow in class. All right, thanks, guys.
They give us like slips for the so that we have the unit circle. If there's one of the unit circle problems.
Yeah, I'll give you a blank unit circle. Mm-hmm.
Are we gonna get like any of the formula things? Or is it mental?
Yeah, you're gonna have to